we would continue immediately with the next presentation, which is the risk or opportunity for material recycling by Christian Lampl. And I see your presentation. You're still on mute, Christian.
Thank you.
Now I hear you. I see the presentation.
Yes.
Try maybe to click forward. Does it work for you?
Yes. Do you see difference? I'm in the first.
We still see the first screen. So I don't think weTHINK has a solution. The solution is that you need to share this screen specifically, I think. Or we just don't do full screen. We don't do it in share mode.
It's moving
like
now. It's moving now.
Yeah, now it's moving. Yeah, let's do it like this maybe.
So I'm again not in the presentation mode. Yeah.
Yeah, do you need to choose another sharing option for the screen? Yeah, I think that's the problem. We can do it like this.
But with Mr. Schneider, it was working. So
he had a PDF.
Okay.
Yeah.
Good. If this is the solution, sorry. So thank you very much for the invitation. It's really a great pleasure to speak about co-processing, and I would like to elaborate a new topic, and I want to go one step further. I do not want to discuss how to avoid landfills, because we see as landfill is gone. So 20 years ago in Austria, we implemented the landfill ban. So the topic, what I see now in the public discussion is co-processing a risk or an opportunity for material recycling? So is it a risk because we hinder the material recycling, or do we support the material recycling? This is the question what I would like to discuss with you. First of all, I have to show you, of course, a small company presentation. Holcim is a global leader in innovative and sustainable building solutions. So we are not just a cement plant. We have innovative other building solutions. We have 60,000 employees. We have a 29 billion franc net sales. A lot of CO2 reduction, a lot of university corporations, and so on. You mentioned already, Ingo, for alternative fuels, and this you haven't mentioned, also for alternative raw materials, we have an organization which is called Geocycle. So it's like a circular economy organization, and we are taking care about the sourcing and pre-processing and co-processing of different wastes as fuel, but also as raw material, as it was already presented by Mr. Schneider and Mr. Grech. Last year we have co-processed 14 million tons as Geocycle. Out of it, 5.5 million tons are alternative fuels, 8.5 million tons as raw material. As you can see here from these figures, raw materials are already more important than fuels, and they are getting much more important because of the issue with the CO2. And Mr. Schneider presented already very well. It's a big pillar for us to reduce the CO2 emissions is also the raw material. We have, as Geocycle, we have reduced worldwide 15 million tons of CO2, and we have reduced also the landfill volumes. We have 60 pre-processing facilities. That means that we are not only co-processing in cement plants, but we have to make pre-processing to be able to co-process in the cement plants. We have 110 cement plants where we are using alternative fuels and alternative raw materials. How I want to explain you now co-processing and the impact on material recycling. Our approach is that it's not just enough to make a presentation and to discuss about it. We would like to have always a scientific basis for it. And because of that, we started a cooperation with the University of Leoben. And we ask actually for a very simple thing. Co-processing is co-processing is for us energy recovery and recycling of minerals simultaneously. This is logic, this is easy, but nobody has proven it on scientific basis. And this was very important for us because this is the basis for further discussions. So we have asked the University of Leoben to make a research project and to find out what are the recycling rates of co-processing. As it was already discussed that we are using alternative fuels as main burner fuel, as secondary fuel. This is shown in this graph. And by using the energy out of it, this is, everybody knows that, it's energy recovery. But, and this is the interesting thing, we can also recycle the mineral content of the waste material because it's incorporated in our product. And the nice thing of this story is that to understand the full picture, you have to understand what are the raw materials of cement. So the raw materials are mainly calcium oxide. This is the most important. Also the reason why we have a lot of CO2 emissions. We need also silica oxide, aluminum oxide, and iron oxide. These are our main components which we are using for the production. And luckily, the fuels which we are using and the ash out of this fuel has a quite similar similar components. That's why we consider the incorporation of the ash in the clinker as recycling, as material recycling. I have to move now for me also something. So this is out and during this research project, and these are now, sorry, Renato and Roland, I'm using now your presentations. This is the result of the ash composition of 30 calciner fuels and 50 main burner fuels. And as you can see, the main components are again calcium oxide, silica oxide, aluminum oxide, iron oxide. These are the main components, and this should show that this is really material recycling. Other components in the raw material, which are also in natural raw materials, are alkalis, is sulfur, is magnesium oxide, and titan oxide. But these materials, these other materials, we have also in natural resources. Here you can see again this comparison. Here, this is the composition of clinker, and the black points are the ash compositions of different main burner fuels, and the blue one is the calciner fuel. And as you can see that we are coming with this ash from the fuels quite close to the clinker composition. As you can see here, you have calcium oxide, silica oxide, and as a base, iron and aluminum oxides. So the ratio of parameters of SAF ash is mostly similar to lignite ash or to lignite coal ash. And the SAF composition is for calcium oxide is between 25 and 50%. So it's a variation. Also aluminum oxide and iron oxide between 10 and 25, and silica between 35 and 55. And as long as you can see there's a variation, we thought about making out of it we have a standard to measure it for each fuel. Actually, it was not really the idea of Holcim or Geocycle. Actually, this idea was developed together with Modern University at Leoben and the ministry, in specific Hubert Grech. They supported very much the development of an ISO standard about this. So the aim of the research work was to develop something which is simple, but also acknowledged a scientific proven methodology. Again, in fact, the topic is easy, but we need an proven, scientific proven methodology to be able to consider it as real recycling. This step is very important, yeah. That you have a methodology how to measure it. The first thing what we have done is we build up a database to compare different materials, and then the target was to make an estimation what is the contribution of the cement industry for circular economy with co-processing. So this was the main target of the research project, and this is the important step, and this is the scientific background of the idea, that you have to develop for everything, for the sampling, for the drying, for the ash, how to measure the ash, what is the analytic method. You need for everything a methodology, and everybody, and the methodologies, and it's important that everybody is using the same methodology, that the results are comparable all over the world. So this was for us very important, that we can compare different fuels and from different countries, and to have the same methodology. This was developed with the university, and the result of this of this analysis, I mentioned before it. There was a database of 30 and 50 samples. The result is that the recycling content of 1 ton of waste, which we are using as for the co-processing, is in average 13.5%. So 13.5% of 1 ton of waste is material recycling, if you consider just the 4 main oxides. If you consider also the minor oxides, which I mentioned before in the presentation, it's going up to 16%, and this was an average of these 80 samples. And here you can see also the difference between main burner and calciner fuels. These results end up then in the ISO standard. The ISO standard was mentioned by Hubert Grech already, because he has implemented in the new Abfallverbrennungsverordnung in Austria. And this, and for us, what we want to achieve with the ISO standard is that we will also have that this 16% or this 13% will be considered also as material recycling by the European regulation. Unfortunately, it was not done in the last change of the waste frame directive in Europe, but the target is that it will be done with the next framework directive change. And the standard says also that you have 2 possibilities. You can do 4 oxides or 9 oxides, depending how much you want to analyze. And we believe that this could bring additional advantages for the recycling industry, because we are bringing recycling to materials which are not recyclable now. So the target of co-processing is not to burn waste which is recyclable, but we believe that we can bring additional recycling quotas for different industries. And the journey will not end at this stage, because we will go the next step. It was already mentioned by Martin Schneider that alternative fuels is a very important topic for the CO2, for recycling, but we have much more potentials, and we have additional potentials in secondary raw material, also alternative raw material, you can call it, or a cementitious material. Cementitious material is the material which it's blended with the clinker. So here we have 3 pillars, and with these 3 pillars, we can contribute a lot to the recycling and to the circular economy. The figures Mr. Grech presented showed already that we have 1.4 million tons of raw materials which we have recycled just in Austria. Austria is a small country. You mentioned in Germany the potential is 10 times higher, and in Europe it's 20 times higher or even more. So there's a lot of potential for the recycling. And this we should not forget when we speak about cement industry. I mean, I'm not speaking anymore about the avoidance of landfill, but for me, it's very important that we are really facilitator for recycling. Here I showed you, and I want to, I have done it in red, that everybody understand. We have 3 pillars: secondary raw material, cementitious material, and refuse-derived fuel or alternative fuel. And everywhere we have an R code. So we are recycling. So raw material is very clear, R5, and this is without discussion. Cementitious is also R5 without discussion. The discussion we have, and which we have to change, is what is alternative fuel. And for us, it's definitely R1, energy recovery, but also R5. And that's why we are fighting for this co-processing idea and for this recycling idea behind. What I want to mention also is that these things, what I'm telling you now, are just able with a very solid legal framework. So what Hubert Grech explained to you, and the legal framework in Austria is really covering all aspects of cement production. So it's covering the input, it's covering the gas, it's covering the cement, and this is very important to develop this kind of ideas. So this legal framework has to be stable and it's the basis of all the developments what we have done. We went one step further with now we have to go back to the university. We said, okay, if we saw that it was a great success to do a simple thing on a scientific basis. Then the next step what we have thought is that we should bring also the other 2 materials, not only the fuels like in the ISO, but also the raw materials and the cementitious materials, we should do also on scientific basis. So we continued the research project, and we said, please do the same, but for the whole recycling content in cement. So put in additionally also raw material and cementitious material. And the outcome of this, and we have done it for our both cement plants in Austria, the outcome is that an average on data based on 2020, the recycling content of cement was in that time, if you put it just on, or if you put it on mass based, that means you just count the tons, then the recycling rate was for our 2 plants were 36 and 48%. If you do it on the oxide based on the standards we have developed also for the fuels, then it's around approximately 35% and 75%, but based on the figures of 2022. And I can tell you now that we have developed, of course, the cement industry is developing very fast because of the reasons which was presented already, because of CO2 and everything. So we have already Siemens where we are above 50% in the recycling content. And 50% in the recycling content is, I believe, a very good figure. But we are producing just in Austria around 5 million tons of cement. Then that means 50% is 2.5 million tons. So there's the quantity behind or the recycling capacity behind this is high. So each industry has the possibility to recycle 2.5 million tons in 1 year. And now coming back to the facilitator for recycling, this is for me a very important thing that, or let's not again on this present picture. Recycling for us, as co-processing count, we want to recycle non-recyclable waste. This is a very important thing for us. We do not want to be a competition to material recycling. We want to be a competition to landfill. We want to be a competition to incineration, but we are accepting the waste management hierarchy here. So reduce, reuse, recycle. This is for us very important. But there are a lot of non-recyclable waste available where there's no recycling solution. I will show you later on examples. And what is also very interesting is there's coming a lot of waste from recycling. I mean, each recycling process is producing additional quantities of waste. And we can provide for these quantities, I call it rejects, we can provide additional recycling quotas for that. And we can support also, this is we can also support recycling technology by providing a fast solution and giving the opportunity to somebody to start to think about recycling. But in the meantime, we take over the recycling for the other industries. And this solution we call co-processing. So, everything clear? Maybe not, maybe yes, I do not know. For me, it's always very important to speak with examples, because for everybody it's much more understandable if you can speak on examples. And I will take one example, a complicated example, not the easiest one. This is end-of-life composites. We heard already that there are people from glass fiber industry are sitting already here in the audience, because they are thinking also how we can recycle material. And their target, of course, is also to make material recycling. And this should be their main target, and this is very okay for us. But the end-of-life composites industry has one problem. They have a long-lasting materials. They should think about recycling, but the collection flow for this kind of materials is very low. So the quantities they are collecting now are so low that it makes no sense, no economic sense to think about recycling solutions, to invest in something, because the material will come only in 50 years, 100 years, whatever. So similar like windmills. Windmills it's a huge topic now, but the quantities really available on the market are too small to invest in real recycling facilities. And the windmills are all over Europe. And then you have five tons today in Austria. Next month you have 10 tons in Germany. So you have a long distances between them. And the advantage of co-processing is that we have existing technology all over Europe. So this is also an added value which we can provide as a cement industry. Glass fiber. Glass fiber is a very good example, because glass fiber has components which the resins is like a fuel, but unfortunately the resins the part of the resins is 30%, and 70% is like it's glass fiber, it's glass, it's a raw material for us. You can see here the content of different end-of-life composites. So again, fuel and raw material bond together. I made this comparison with Portland cement and the glass fiber components. What are the composition? And what we can do with this kind of composite material is that the raw material is 70% is raw material, 70% is material recycling by law already now. So we can use the composite waste as raw material. We can we are preventing or we are reducing the usage of natural resources, and with the calcium oxide content inside, we are reducing even the carbon emissions. For the polymer fraction, which is 30%, could be used as alternative fuel. Of course, this is a presentation. It's not so easy to. We have to think about pollution for the employees, and there's a technology behind it. You cannot do it. You cannot take just a pipe and put it in the cement kiln. So there is some pre-processing behind. But what I want to show is it's possible, and we have the solution all over Europe, because we have everywhere co-processing facilities. And we have made trials already in our cement plants in Austria. We have done trials with this composite materials already. It works well. We have done it also we have made also measurements because of the health aspect. So from our point of view, it's possible and it's doable. And because the cement in co-processing offers a sustainable recycling solution for 100% of the material, and the cement co-processing can offer recycling on a large scale immediately. And because the cement itself can be recycled 100% without, also very often, there's because of that, there is now existing a position paper between Sembiro and the composite end-of-life composite producers to be a partner, to build up a partnership for the recycling of this composite material. This position paper is available on the Sembiro homepage, but only to the point when the end-of-life composite material producers will deploy their own recycling material. And in that moment when they deploy their recycling facilities, they still will have again waste which we are able to recycle. So this is what I mean with the cement industry is a facilitator of recycling, of material recycling. And I want to show you other examples which are going in the similar direction. Tire textile, also tires. If you recycle tires, you're producing granulates, you're producing iron and textile. The granulates, this is actually the main recycling material they are selling. The metals they are selling also as a scrap to the iron furnace. But for the textile, still there's no solution. And we can provide for this textile and recycling or a co-processing solution, because it's a quite interesting material for us. It has high heat value and it has no chlorine. So it's a quite interesting material, and we are supporting the recycling industry. Otherwise, they have to landfill it, or they have, I don't know what they would do without the cement industry. This is one example. Again, we are facilitators of recycling for other industries. Rejects from plastic recycling. Very often I hear the complaint that we are co-processing plastic, and because of that there's no plastic recycling. For me, this is completely nonsense, because first of all, we are processing material which is coming out of a sorting process. So what the sorting machine do not consider as recycling material, we are getting it, we are taking, and we are making fuel out of it. This is the first step. And the second step, if the granulation, the companies which are really producing plastic granulations or plastic granulates. They are producing also waste because they have rejects in the material in their input, and these rejects we are also able to recycle. A question which I received very often is, are you not afraid that if everything will be recycled, that you have no fuel anymore? My answer is always, I hope that there will be much more recycling in Europe, because if there's much more recycling, we have much more alternative fuels even with a good quality, because these fuels, these rejects from plastic, this is a good quality fuel. So we are supporting it also because we will have more fuel. Compost oversized material, another example. After composting, you are sieving, you're taking out the big wood pieces to use the fine compost. Because the collection with the collection you get a lot of plastic as an input. This wood after sieving has a lot of plastic inside. So we can use this compost oversized, because first of all, the plastic is do not harm us, because we are co-processing plastic. Plus the wood is biomass for us, but it's wood which they cannot reuse again, because if they would reuse the mixed plastic and the wood too often, you have again the microplastic discussion in the compost. So again, we are supporting, we are facilitating recycling with our technology. And then we are coming to the real recycling, or not the real recycling, our recycling. We are doing, of course, also recycling not only for other industries. We are doing recycling also for us. So we are bringing material. We are producing building materials, and we are able to reuse and to recycle. I had a discussion about reuse and recycle. Sometimes we are even reusing it, but we can reuse and recycle our construction building materials in our own process. This is maybe in the 1.4, 1.5 million tons raw material which was presented by Hubert. The main part of it are waste bricks and concrete. This is the main raw material part in Austria when you see the statistics. Gypsum plasterboard, a quite interesting topic, very controversial discussion in Austria, because there's a landfill ban for gypsum plasterboard starting from 2027. So there are a lot of recycling facilities, or not a lot, but some recycling facilities will be developed till 2027 to avoid landfilling. And also here, if it's necessary, if the gypsum plasterboard industry is not able to recycling their waste themselves, we are able to reuse and also to co-process the carton and also the gypsum, because gypsum is part of our cementitious material. So we can reuse the material out of the recycling, also for the gypsum plasterboard. Similar thing also for mineral wool, where we have also a landfill ban in Austria, where we have also developed in a research project together with another partner. We have also developed a stabilization of the mineral wool, also because of health aspects. And we are also ready to recycle this mineral wool, because there is a silica content, there's also a calcium content. And again, we will facilitate the recycling of this kind of materials. And I hope that with the examples, I could explain what I wanted to express to you. So material recycling is the key job of a geocycle manager. Material recycling, we want to support all kinds of material recycling, also from other industries. And our technology is very flexible. And if you have also the right legal circumstances, then there is also no risk for the environment if to co-process these recycling materials. So thank you very much for your attention, and I hope that that you are promoting this idea of co-processing and recycling also all over the world, that we will be considered not anymore as incinerators, but as recyclers. Thank you very much.